Hey guys, just looking at the last section of chapter 13, 13F from Fundamental Applied Maths. This is page 234, questions 4, 6, and 11. So we'll start off with question 4 here. A simple pendulum consists of a particle attached to one end of a light inelastic string, the other end being fixed. The periodic time is 5.5 seconds. Find the length of the string to the nearest centimeter. So here's our periodic time. Here's our string, which unstretchable and has no mass. One of our light inextensible strings. It's just a medium for tension, basically. Find the period. Sorry, find the length. So if the period is 5.5, we can plug that in there. 5.5 seconds equals 2 pi root L over G. And it's just a matter of solving that for L is all we're doing in this question. So 5.5 divided by 2 pi is 0.875. So we get 0.875 is root L over G. So we can say L over G is 0.875 squared. So that number squared is 0.766. And our length then is that number multiplied by G. L times 9.8 is 7.5091 meters. They've asked to the nearest centimeter, so 751 centimeters is the length if you wanted to have a period of 5.5 seconds. So it's quite a long pendulum. Question 6. The lengths of two simple pendula, the plural of pendulum, are in the ratio of 4:9. Find the ratio of their periodic times. So we're told that the first length is 4 L's and the second one is 9 L's. That's a 4:9 ratio. Find the ratio of their times. Okay, well, our periodic time for the first pendulum is going to be 2 pi root 4L over G. I'm going to take that root 4 out, okay, as root 4 times 2 pi L over G. Okay, and I'm going to call that 2, and I'm going to call this, I'm just going to call it T, which is, so twice some time given by that. T2 is going to be 2 pi root 9L over G. I'm going to take the root 9 out, times 2 pi root L over G. Okay, so that's a common theme in these questions, the 2 pi root L over G, which is what I called T earlier, so that becomes 3T. So these are in the 4:9 for length, corresponds to a 2:3 ratio for period. So you can see there it's a square relationship or quadratic relationship between them. Question 7, I'm just going to address quickly here because I like it. I'm not going to do anything with it. If a grandfather clock were moved to the moon, would it go fast or slow? Justify your answer. So grandfather clock, if you're not too familiar, is a simple pendulum, and that's what mediates the time. That's how they kind of regulate their time. So you've got a simple pendulum moving back and forth. Usually the period of the pendulum is 1 second. That's how they work. So they've picked the length so that the period is 1 second. If you brought it to the moon, the gravitational pull is the only thing that would change. Okay, the length would stay the same. So G would be smaller. So you get a smaller number in the bottom of this fraction, which would make my period larger. Okay, so it's now going to move slower. It's going to take a longer time to complete one full oscillation. Question 11 says the acceleration due to gravity on the moon, so another moon question, is 1/6 of that on the Earth. A pendulum on the Earth and one on the moon have lengths in the ratio 8:3. Find the ratio of their periodic times. So kind of similar to question 6. We're told gravity on the moon is Earth's gravity divided by 6. We're told our lengths are in an 8:3 ratio. So I'm going to say L1 is 8L and L2 is 3L. And now we've got an 8:3 ratio. So the period of the first pendulum will be 2 pi root 8L over, now the 8 one is on the Earth. Okay, Earth to the Moon is as 8 is to 3. So that's on the Earth, so that's G. And that's going to be root 8 times 2 pi root L over G, which we saw up there already. Okay, so let's call that root 8t. T2 is going to be 2 pi root 3L, but now it's G over 6. Okay, because we're on the moon for this one. Multiplying top and bottom by 6 there gives us 2 pi root 18 L over G. And taking out our root 18, we're going to get root 18 times 2 pi root L over G. Okay, so root 18 T1, or T. So our ratio, as 8 is to 3 for length, is as root 8 is to root 18 for period. Now that simplifies. That is 2 root 2 is to 3 root 2. So that's a 2 is to 3 ratio for the period. Okay, as usual, plenty of other questions there. This section isn't too bad at all. I'd encourage you to give it a go. Have a look through the summary of important points at the end of the chapter, the do's and don'ts, and we will hopefully get some exam questions up as well. Okay, but that's the end of that chapter. Best of luck with simple harmonic motion and circular motion. They're combined question on the papers, and I'll see you for the next topic. Bye bye.